This is an entry for the encmp 100 programming contest, and my entry is a genetic algorithm for solving a platformer made in Matlab. On the side of your screen you should be able to see the program actually executing, but what does it do? So it attempts to emulate evolution to solve a platformer by using a genetic algorithm. In order to accomplish this, you need hundreds of generations, each with several characters. And there are four main parts to it. The first part is that you need to actually run the character and have it run the platformer based on its genome. And then the second step is you need to select the characters that you want to breed based on a fitness, and then you need to breed and then mutate the characters, and then you just need to repeat it over and over again. So as mentioned before, each character has a specific genome. But what does this genome entail? It is composed of a series of actions, and each action has a specific time and a speed characteristic. Now, each action also has a type, and the two types that are in the program are jump and move. So the platform then loops through each and every character, executing each and every action in the character's genome until the character either dies or it reaches the end. If you look at the top left of the program, you will see the trajectories of the character, and that is reflective of the character's genome. Once a generation is actually run, new characters need to be made based on the breeding of the old characters. In order to accomplish this, first characters are evaluated producing a fitness value, and this fitness value is the sum of the distance travelled and the time that each character is alive for, minus the energy that the character uses, and then all of those are multiplied by a specific weighting, and the resulting number is then raised to the value of a differentiation factor. This differentiation factor actually separates the characters. So for example, with a high differentiation factor, characters that are fit and characters that are not so fit will have a greater difference between them in terms of fitness. The characters are then sorted based on their fitness, and then the breeding pairs of the characters are selected using a roulette wheel approach. This works by taking all of the characters and allocating each character a specific portion of a pie depending on the fitness of the character. So characters with larger fitness in relation to others will get a greater portion of the pie. Random numbers are then selected, and then they are allocated to characters based on their portion of the pie. So this means that characters with greater fitness values will be more likely to be selected by these random numbers, and then you just do this for all the different characters until you have selected enough to create the next generation. Then you actually need to breed the characters. In order to do this, what you do is you select a random point in the middle of the genome, and you say up to that point you're going to choose one parent's genome, and beyond that point you're going to take the other parent's genome, and then you just go and you combine the two together. Also, while in real life, essentially you have two copies of the same genetic data with some minor variations. In this implementation, you only have one chromatid or one copy. The characters are then mutated, and there's three different ways this is done. You add an action, you remove an action, or you simply change a characteristic of an action, so like the time or the speed with which the action is performed.